Welcome back to The Explainer. Today, we are diving straight into the third entry of this developer's journal, and we're tracking a really fascinating transition. We're going from a completely crashed prototype, what we call version 4, all the way to version 5, which is a fully rebuilt, totally distributed architecture. So if you've ever wondered how an AI actually learns from its own catastrophic failures to come back sleeker and smarter, you are in exactly the right place.
You know that old military saying, no battle plan survives first contact with the enemy? Well, it turns out that's absolutely true for building an AI from first principles, too. The creator of the PFVME project found this out the hard way. But here's the thing. Every single discarded version, every frustrating week of lost work, none of it was actually a setback. Those failures were the exact stepping stones needed to push this project toward a much more coherent, elegant design.
And this whole journey really highlights a massive shift in how development even works now. Think about it. In the past, a solo developer would spend months writing code, right? And they'd get trapped by the sunk cost fallacy if they hit a fundamental flaw. You just wouldn't want to throw away all that hard work. But today, AI itself acts as a collaborative partner. It lets a single researcher rapidly experiment, instantly toss out bad ideas, and just rebuild on the fly. It has completely shattered the barriers that used to make a project of this scale impossible for anyone without a massive corporate team. Now, before we get into the shiny new version 5, we really need to talk about what happened with version 4, because version 4 actually succeeded at a brilliantly simple yet incredibly difficult primary goal: continuously observing the world and learning what remains stable. Imagine just staring out of a window. A tree is fixed in place, sure, but its branches are swaying in the wind. Shadows are shifting across the grass, birds are landing. Everything is changing, but it all follows patterns. Version 4 didn't try to name any of those objects. It just tirelessly observed them to map out the predictability of its environment.
And this is where things get really wild. Because version 4 eventually made a massive leap. It shifted from just passively watching reality to generating its own primitive questions to try and explain the physical world. It started asking itself things like, wait, is this object independent, or is it attached to something else? Or does movement in this one spot predict movement over there? The system was actively trying to construct an explanation of reality from the chaos of its environment rather than just waiting to be spoon-fed rules by the developer. So, it was working perfectly. For 2 whole days, it steadily accumulated data, generating about 200 gigabytes of solid observations. But then, it completely lost its mind. In a chaotic span of just 12 hours, the system wildly devoured its remaining 300 gigabytes of storage and just crashed hard. I mean, the drive filled up so fast that it wiped out any chance of even generating diagnostic reports. Now, hold on, let's be clear. This wasn't some creepy sci-fi movie moment where the AI suddenly woke up or gained consciousness. There is zero evidence of that. The working hypothesis is actually what's called a combinatorial explosion. See, once the AI's environment reached a certain level of stability, the sheer number of possible relationships it could explore expanded exponentially. It started connecting so many incredibly complex combinations of observations that it literally thought itself into a standstill. And that spectacular crash, that's what forced a total architectural rethink. Realizing that the underlying infrastructure matters just as much as the intelligence itself, the creator looked directly to biological neuroscience for version 5. They completely abandoned those old clunky ideas of a conscious and subconscious system, because frankly, that's not how our biology actually works. The human brain is a bunch of specialized systems working simultaneously, not one giant central processor. So, to stop the AI from crashing under its own weight again, version 5 had to mimic this distributed approach. So let's break down how this new distributed architecture actually functions, starting with the very first component, the eye. This is an entirely independent subsystem, running on its own machine, dedicated to one singular task: just observing reality. It streams a continuous view of the environment, and here's the crucial part. Its job is absolutely not to interpret the world or figure out what things mean. It simply provides a perfectly accurate live stream of the present moment for the rest of the network to use. Next, we take that raw, unfiltered data from the eye and feed it directly into the spatial perceptual system. You can basically think of this as the AI's first brain. It is totally grounded in physical reality. By monitoring what stays stable, what changes, and what moves independently, it acts like an attention filter. In short, this machine is constantly asking one foundational question over and over again: what actually exists? Okay, so once we know what exists, we pass that information up to the analytical conceptual system. This is the second brain, and it operates very differently.
By separating the perception side from the reasoning side, this system doesn't have to waste processing power trying to figure out if a shadow is moving. It just takes the physical evidence and focuses entirely on building concepts, relationships, and eventually, symbolic understanding. Its one and only job is answering the question, what does this mean? Of course, none of this works without memory, but remember how the old memory system essentially became a massive, bloated database where data just piled up until the whole thing died? Yeah, they fixed that. The new memory system dynamically coordinates development. It's this evolving, highly organized collection of experiences and performance metrics. The other systems can retrieve exactly what they need, precisely when they need it, and not a millisecond before.
I absolutely love this next distinction. Because when we look to biology for inspiration, we still have to respect the limits of the digital world. I mean, forcing an AI to feel hungry or fear predators is completely artificial and kind of silly. A digital system's survival genuinely relies on the things it actually controls. So, version 5 develops digital survival goals, controlling its camera, directing its attention, and properly allocating its processing resources. Managing its hardware is its equivalent of taking care of its physical body.
So how do we prevent the system from ever experiencing another 300 gigabyte data crash? Version 5 ditches monolithic processing entirely. Instead, it uses what are called buses. Think of these as a fleet of highly specialized digital workers. Instead of one massive computation trying to solve the entire universe at once, the system launches dozens of these small, independent buses simultaneously. One might go fetch a memory, another might explore a spatial relationship. They go out, do their specific job, and bring back only the relevant information. All right, so how does this whole modular orchestra actually play together? It runs through a highly structured processing cycle. First, the eye observes reality. Then, the systems launch their independent buses. Memory jumps in to provide the relevant context and goals. Then, actions are selected and executed. And finally, the eye observes the outcome of that action to update the AI's predictions. This constant looping cycle is what guarantees continuous learning, updating the system's confidence with every single action it takes.
But here is a crucial point. An AI cannot truly improve if it doesn't evaluate its own performance. That's why version 5 introduces a reflection subsystem. Periodically, the system literally pauses to evaluate itself. It asks, okay, which predictions proved correct? Which routes totally wasted processing power? What should I try differently next time? Because without reflection, a system just hoards data. But with reflection, it transforms raw experience into genuine behavioral improvement. Right now, as the spatial perceptual system comes fully online, the immediate goal is deceptively simple: learn what normally happens. The challenge isn't to just ignore all movement, it's to build a reliable internal model of reality. The system has to teach itself to safely ignore a bush just swaying naturally in the wind, but immediately trigger an investigation when a bird suddenly lands in that exact same bush. It's exactly how your own brain filters out the background noise of life to focus on what actually matters. Zooming out for a second, this entire journey of rebuilding PFVME proves something really profound about the era we're living in right now. While scientific progress will always rely on learning from our failures, modern AI has become the ultimate catalyst. It is actively empowering a single developer to explore, experiment, and build these massively complex distributed architectures that just a few years ago would have required giant teams and endless funding. Which brings us to a truly fascinating thought to wrap up on. For the first time, this project isn't just a collection of disconnected, crash-prone experiments anymore. It is a true, stable foundation. So as version 5 begins to successfully construct a reliable internal model of physical reality from scratch, what completely new concepts, relationships, or even languages will its analytical systems eventually invent to explain what it all means? It is a thrilling question, and I absolutely cannot wait to see where this architecture goes next. Thanks so much for joining me on this explainer, and keep learning.